Hello. Can I
Hello.
ask a question?
Sure.
Every time I click on build, I get an error, a network error. I don't know where the problem is.
What is the error exactly? Could you send it to me?
It
You can
just
send it to me on Slack.
on Slack. Okay.
Yes.
Perfect. Thank
you. Okay, so I think I will start with saying that I already uploaded the video to YouTube. I mean the lecture video, so you can look at it if you want to. Yeah, so I think right now I'm going to go through the code and the tasks, and then I will let you work on the remaining part. So, and I will stay here for questions, obviously. So as I said, we have tests, and to run the tests and see the results, you need to install this library, the PyTest library. I have two terminals right now open. I need a third one. I have this in here, and I think I already installed this. Yeah, but I'm not on the right, not in the right environment, so I need to activate the PyNLP. I'm in the right path, so you need to be in directory of the repository. I'm here, and if you run, I think it's Python. And we have two failed tests. Those are the unfinished functions. You can see it here below that 4 tests passed because we have those implemented, and we have 2 fails. If you look at the tests, it works with I have a test file here, and the tests work with that. So it doesn't work with the whole data set because I want it to be run quickly. So I just have a smaller data set for testing. And it initializes the knowledge base with the test files. And the tests are for building the knowledge base, for querying the neighbor, with the distance, and also the test character with the most connections. And at the end, we have 2 more functions, the isolated characters and the shortest path between 2 characters. And you can see that I'm calling a function in the knowledge base. I'm running the Streamlit and the server, so I didn't quit those. I don't think I understand the question. So which enter a path to serialize the knowledge base graph to? You should run the front end, so the Streamlit application with this. It's quicker because this way you don't need to build the knowledge base because I have it pre-built. So if you run with this, the first command, then you don't have this, the build knowledge base. So you need to build it, and then you need to give a path that it will be serialized to. You can give it any path if you want to. But I suggest you to using this command because it will be quicker right now. So I will open the code itself. So where do we start it? I think we start with the knowledge base or knowledge graph. Basically, it's a wrapper around the network X graph. So at the beginning, you see here that I initialize an empty knowledge base, an empty network X graph, and then I build from those. So first I need the characters. I have a file for that, the characters.txt in the data folder, and I just read it line by line, and then add the characters to the list that I have here. Then I build the first names of characters. So because we have the full name in the characters file, and for example, Jon Snow and Ned Stark and so on, but usually it is not mentioned by the full name. So just like John and Ned and so on. So I also build a dictionary with the first names, so John and so on. But the problem is that there might be multiple Johns in the characters, but then we won't know which one it refers to. It is a language processing task, basically. Sure, I will zoom. What is the zoom command? Control. Yeah, this one. Is it better now? So I'm using a default dict, so a dictionary with integers that starts from 0, and for each mention I add one to it, and that is because I want to know if there are multiple characters with the same first name. If there are, then I don't want to recognize that character with that first name, because then we don't know which one it refers to. So if there is only one John, then I do the first name recognition also. Then I also read the aliases for the characters, which is a dictionary, basically. It's just a dictionary with keys and lists. So like Balon Greyjoy can be known as Balon the Brave, Balon the Blessed, and so on. I do that because if we recognize an alias, I also want to add that to the character mention. And then I compile regular expressions for each character. I do this because we need to run the matching a lot. So the first book has around 25,000 lines. And for each line, we want to know if there are, for each character, for each line, we are running the matching. So that's a lot of matching. And it would be pretty slow if I would just use like simple matching. And that's why I'm using a regular expression, and I compile it at the beginning. So that means it will be much faster if you compile the regular expressions, and then you are doing the search with the compiled regular expressions. So I have this function, the compile characters regular expression, which basically just go through all the characters and it builds the regular expression. It's pretty easy. I mean, I just want to know if the character is in the line or not. These bees means that there is a word boundary. So I don't want to match substrings. So if a name is in another name, I don't want to match those. I just want to match whole words. This is why these are for. And I also add also build the other regular expressions for the first names and then for the aliases. So it's just building, and then we go to matching. But first, we have a condition here whether we provided the serialized knowledge base. So should we only just deserialize it with the networkx function, or do we need to build it from scratch? That is why I said use the second command, because there we have the serialized knowledge base. So we don't need to do the whole matching. And the serialization uses networkx built-in function, which basically just converts the knowledge base into a big JSON format. So, and we can read it after. So I also recommend to you to use for serialization and the networkx. I recommend to use the JSON format and not the pickle format, which is just a binary version of the object. Because then if you will have another version of Python or networkx, it might not be convertible. I had that problem before. So now I'm always trying to use JSON or something like that. It is bigger than the binary one, but you can open it from command line. It won't have these version mismatches and so on. Okay, and so I have a build function here, which basically just reads the book line by line. I open it, I read each line, and then I go through the characters, and I'm looking for character matches here. And if there are character matches, then I have a list, and I append that character to that list. And if there are multiple matches, so there is not just one character in that line. If there is just one character, I just add the node, so I don't add any edges. If there are multiple characters, then for each pair of the characters, that is why this pairwise function is here. It basically generates pairs from a list for us. I add an edge between those two characters. And if the edge is in the knowledge base, then I just add the node, add the one to it. So we increase the weight of the edge by 1. So I mean, for each mention, I just add 1 to the weight. It's pretty simple. And that was the building of the graph. Here we have the algorithms that returns something for the front end. How does it look like? I will open the backend here. The zoom overlay is pretty annoying. So we have a Flask service here that builds the web service for us. So then we will have a web service running on localhost, and then the front end can query it for the information. Yes, you are allowed to use anything. So built-in algorithms are completely fine. I'm also using the built-in algorithms. So you mean built-in in networkx, I guess. Yes, you can use that. So for example, I have a root here, build, and if the front end calls this, we build the knowledge base. And if there's a path provided, then we build it from path. And if there is no path, then we build it from scratch. And we also have all the functions implemented here. So, for example, getting the nodes of the characters. The JSONify method converts the return value to a JSON object, and then you need to read that in the front end. Let's look at an example. For example, the neighbors root. It expects two arguments, a character name and a distance. So do we want only the immediate neighbors, or do we want the neighbors of the neighbors also? If there is a distance provided, then we use that as we set it to 1. If we didn't build the knowledge base, then we return an error that the knowledge base are not loaded yet. So first you need to load the knowledge base. Then we call get character neighbors in the knowledge graph. Here with the provided character from the front end and the distance, we can see the implementation here. So with the provided character, we just run networkx built-in function with a search in the graph, breadth first search. So not depth, but breadth. So we start with the neighbors and then the neighbors of the neighbors. And you just need to specify the source character and the depth limit. And we have both. And it basically just returns the edges. So you have it directly. I converted it into a list from the built-in class. And basically, I just return the subgraph of these edges. And with that, for that, I can use the edge subgraph method, which expects an edge list, and it returns the subgraph that only contains these edges. And then we return the subgraph here, which is a networkx object. It is important. And we get this object here in this function. And here I convert it to the JSON format, so I can return it through the web service to the front end in a JSON format, and then the front end can do it with it whatever it wants. I mean, it can use the networkx to convert it back to the networkx object, or it can use it as it is. And how does the front end look like? We can go there now. It is a Streamlit application. We know that. It starts from here because we run it from the command line. So first we need to get the arguments it was run with in the command line. For that, I wrote a little function. It basically uses an argument parser module. You can see here that we can provide the knowledge graph. By default, it is none. So if you don't provide anything, it will return none. And as it is a string object, so it is just a path of that file. And then I call the main function with these arguments, which will be here. So first, I set the page config so it is wide, wider than usual. You can also use Markdown directly in Streamlit. So I used Markdown for the titles and headers here. Then I call the init session states method, which is a method in the util file. It initializes all the session states of objects that we want to persist. I thought about it when I introduced Streamlit. Basically, I just introduce the session state variables, like was the knowledge base built or not, what is the current graph that we want to display. Sorry, I lost the content. And that first, I have that part that are this. This is for building a knowledge base. It is with an expander, so you can expand it or not. So you can close it if you don't want to see it anymore. And when you click on the build button here, it will set the session state variable build to true, and then you can display the rest of the app here. So we set two columns to the layout. We wanted to have two columns. So in the left side, we have the query algorithms and so on. On the right side, we have the displayed graph. So, but we only display it if we already built the knowledge base, because otherwise we couldn't query anything. So first we need to get the characters, because we can choose the for example, in the neighbors, we can choose which character we want to query. These characters are returned from the knowledge base. These are the nodes of the knowledge base, and this get characters is implemented here at the top of the page. This is basically just uses the requests package to make a request to the backend of the application, and it returns the response as a JSON object. And the note here that I have used the cache decorator here. This is built in Streamlit. It basically lets you define a cache. So if we run it multiple times, it won't make a request to the backend, because if the inputs are the same, it will just return that input from the cache. So it won't make new requests to the backend each time it was called. And then we have basically we have the algorithms here. First, I just define the select box that with that you can just select the query type that you want to make. These are the algorithms that were implemented, I mean most of them. And then this is just a basic if else part of the file. So if the query type is neighbors, then we call this function the query neighbor function, which is defined at the top of the page, and it makes a request to the backend and returns the response as a JSON object. And basically we just display the results here, and we don't really implement any kind of algorithms, except the conversion of the JSON object to a networkx graph. Yeah, the JSON to networkx and are defined in the utils function. It basically just reads the graph with the built-in networkx function that converts the JSON to a networkx object. So we can use then we can use the networkx object as it is. And so the current graph is always in the session state, so we can use it always, and it won't refresh. The only time it refreshes if we set it again to another graph. And then in the second column, we display the graph, and we use the installed module for that. So we use the agraph, Streamlit agraph module for that. It is also implemented in the util file. Basically, we just convert the edges and the nodes from networkx to the visualization library that shows the graph that you have seen in the front end. And you have two tasks here that are not implemented. I mean, I wrote that it is not implemented. Everything is implemented in the front end. So let's say we want to work on the isolated characters task. It says it's not implemented yet, but if you uncomment it, the front end, in the front end, it will appear. You just need to implement it in the back end. So basically your task is to complete this function in the knowledge graph.py in the PyNLP package. I also marked it here. So the task 1 and the task 2. The first task will be, I wrote the descriptions here. The first task will worth 7 points. The task your task will be to find isolated characters in the knowledge graph, which means nodes that don't have any neighbors. They don't have edges, outgoing or ingoing, so they are isolated in the graph. That is the first task that we need to complete. So I think the first we can do it together, and then the second task will be finding the shortest path between two characters. So in the front end, you will need to provide two characters. So for example, Sansa Stark and Jon Snow. And in the backend, in the knowledge graph, you can use the built-in functions from NetworkX. You need to find the shortest path between these two. So something like this here in this graph. This is the shortest path. By shortest path, I mean the number of edges. So you don't need to take into account the weights here, because that would be a hard problem. I mean, we don't want the weights to be a small number. I mean, we want to maximize the weights to find a path where the characters were mentioned together a lot. So if we would take the weights into account, it will be a much harder problem, because we would like to maximize the number of weights, but minimize the number of edges, and that would be an optimization problem. So, but that's harder. You can think of it if you want to, but it's not part of the solution. Also, for the second task, you have everything implemented in the backend. So you have the route here, the shortest path. It will do everything for you. In the front end also, you just need to uncomment these lines and delete the error. And it is basically just selecting two characters and calling the shortest path function. It is also implemented here at the top. Here, it will make a request to the backend of the application. And basically, you need to return two things. First, the path itself as a subgraph, and also the sum of the weights in the path. So you need to add together all the weights and also display it in the info variable. Okay, so let's do the first exercise together. I just and I want to uncomment this. So in the front end, it will be displayed, and I think it's better to first complete this, and then you can test it before going to the front end. You can test it with the PyTest, so it's implemented correctly, because then if you do this, you will get an error in the front end. So I will do it back, and then first we will complete the backend. So the isolated characters, It doesn't have any parameters. You need to implement these. And first we need a list. And basically, NetworkX has a function for that, exactly what we need. It's called isolates, and basically it is a node with no neighbors. So we exactly need this information. We need a list of these characters, and we just need a subgraph of these nodes. And in the backend, you can see what you need to return. We need to return the characters itself, so a list, and also the subgraph. So I will return the list of the characters and the subgraph also. Yes, and now we can test whether the test is running. Yes, we only have now 1 fails and 5 passes. So the function works. And now in the front end, I can just uncomment these, comment the error, and then I rerun the Streamlit and click on the isolated characters, and I'm getting a JSON error also. So something is not okay. Okay, the problem is that Streamlit is caches things a lot, like frequently. So if you make changes like this, always try to clear the cache first and then rerun the application. Build the knowledge graph again, and then click on the algorithm that you want to run. And here are the the isolated nodes, so you can play with these if you want to.
Can you show us the code you wrote again, because it was pretty fast and I get a few errors, so I have to figure out what exactly happens in the few lines you did. Also, with just one screen, it's not so easy to see everything.
Yeah, I can imagine, yes. And about the shortest path, the tricky thing will be that if you use the built-in algorithm, it will return nodes, and that list of nodes will be the shortest path. But then if you call the subgraph method with those nodes, it will include all the edges between these nodes, not just the shortest path. So what you need to do is to get the edges directly from the list of the nodes. So the first 2 nodes and the edge between that node, then the second and the third node, get the edge between that node, and then make this subgraph from that path. Because otherwise you will also get some additional edges. Yeah, so that can be an error, but I think the test won't fail if you do that, so it's fine. But I'm just saying, so I think we have some questions in the chat. Sorry. It's also not easy to see the chat and then talk and just show you the code. I also have to I have a notebook here with the video, and then I have a PC that I'm showing you the screen. So I need to pay attention to both, and also read the chat. So
I will read you one question
no,
from the chat if you want.
I'm seeing it now. Thank you.
All right.
What I did is that in Streamlit you can click here, and then it has an option clear cache, and then I cleared the cache, and then I clicked rerun again. So I rerun everything from scratch because something might cached in your browser that caused the error, I suppose. I'm not exactly sure that was your problem, but I also got a JSON decode error, so that might have been your problem. Okay, and you have one task left, so I will let you work on it, and then you can ask questions if you are stuck. I think I'm going to stop